Here we have AP calculus AB problem. Okay, let's go with information. Here we have a piecewise function f of x. That is f of x equals to x squared positive 2x positive 1, x less than or equal to 0. F of x equals to 2x positive 1, x greater than 0. Circle any true statements. We have three statements over here, A, B, and C. And we have to circle the true statements. Okay, now let me verify the statement A. That is, f of x is continuous at x equals to 0. To check whether the function f of x is continuous at x equals to 0, I have to verify three conditions. The first condition is I have to plug in this 0 for x over here. Then I'm getting f of 0. The value of f of 0 has to be defined. Let me write the stuff over here. And now in my second step, I have to evaluate the limit x approaches this value. That is, x approaches 0, f of x, and it must exist. Let me write the stuff over here. And the third step is the values I got in step 1 and step 2 must be equal. That is, f of 0 must be equal to limit x approaches 0, f of x. Okay, so if all these three conditions are satisfied by the given function f of x at x equals to 0, we can say that the function f of x is continuous at x equals to 0. So for that, let's do the first step. That is, we have to evaluate the value of f of 0. So f of 0 means like in the given piecewise function of f of x, we have to consider the piece where x equals to 0. So that is the first piece, because at where we have x equals to 0, x is less than or equal to 0, that means x can be equal to 0. So when x equals to 0, we have the piece f of x that is equal to x square positive 2x positive 1. Now I have to plug in x equals to 0 here. When I do so, when I plug in 0 for this x, 0 square is 0. When I plug in 0 for x over here, 2 times 0 is 0, positive 1. So finally, I'm getting f of 0 equals to 1. Okay, now I have to evaluate limit x approaches 0, f of x. But f of x is a piecewise function. Since f of x is a piecewise function, to evaluate limit x approaches 0, f of x, that is the ordinary limit of x approaches 0, I have to evaluate the left side limit of 0 and right side limit of 0. Both of them must be finite and equal. Then only we can say that the ordinary limit of x approaches 0, f of x exists. So first, let me evaluate the left side limit of x approaches 0, that is x approaches 0, negative f of x. So here I have taken a negative sign on the right side top corner of 0. It indicates x approaches 0 from its left side. Let me draw a number line over here. When x approaches 0 from its left side, all the values taken by x over here are less than 0. That is, x is less than 0. When x is less than 0, what is the piece we have for f of x? Clearly, x squared positive 2x positive 1. This is the piece we have for f of x when x is less than 0. So we have to plug in this stuff for f of x over here. Then I'm getting a limit x approaches 0, negative x squared positive 2x positive 1. So this negative sign has nothing to do with the calculation part. It just indicates the left side limit of x approaches 0. Now we can plug in this limit 0 for x over here. When I do so, when I plug in x equals to 0 over here, 0 square is 0. When I plug in x equals to 0 over here, that is 2 times 0 is 0, positive 1. So I am getting 1. So the left side limit of x approaches 0 for the function f of x equals to just 1. Now let me evaluate the right side limit of x approaches 0 for the function f of x. Here I write a positive sign. It indicates x approaches 0 from its right side. When x approaches 0 from its right side, all the values taken by x are positive, because here all the values are positive. That means greater than 0. That is, x will be greater than 0 when x approaches 0 from its right side. Now we have to consider the piece of f of x where x is greater than 0. Clearly, this is a piece we have for f of x where x is greater than 0. Now we have to plug in this 2x positive 1 for this f of x over here. Okay, let me continue. Limit x approaches 0 positive 2x positive 1. So this positive sign has nothing to do with the calculation part. It indicates that x approaches 0 from its right side. Okay, in my next step, I have to plug in this limit for x over here. That is, I have to plug in this 0 for x over here. Then I'm getting 2 times 0, positive 1, which is 2 times 0 is 0, 0, positive 1. Finally, I'm getting 1. So the left side limit of x approaches 0 and the right side limit of x approaches 0 for the function f of x are finite, and also they are equal. Since both the left side limit and right side limit of x approaches 0 are finite and equal, then the ordinary limit, that is limit x approaches 0, f of x equals to 1. Since the left side limit of x approaches 0 and the right side limit of x approaches 0 for the function f of x are finite and equal, so the ordinary limit of x approaches 0 f of x exists, and whatever value we are getting for the left side limit and right side limit are the same values taken as the evaluation for the ordinary limit. Okay, already we got the step 1 value, that is f of 0, it's over here, it's 1, and now we got step 2 value, that is limit x approaches 0 f of x, it is equal to 1. So according to the stuff I have explained over here in step 3, so the value we got in step 1, the value we got in step 2 must be equal. So the step 1 value is just 1, step 2 is value is also 1. So both of them are equal. So the given function f of x satisfies all the 3 conditions over here at x equals to 0. So therefore the given function f of x is continuous at x equals to 0. So statement A is true. Now we can check the statement we have in B is true or false. That is limit x approaches 0 f of x equals to 3. That is ordinary limit of x approaches 0 for the function f of x is equal to 3. Actually f of x is a piecewise function and also 0 is a transition value. Okay, to evaluate the ordinary limit of x approaches 0 for the function f of x, what I have to do is I have to evaluate the left side limit of x approaches 0 for the function f of x and the right side limit of x approaches 0 for the function f of x. Both of them must be finite and also both of them must be equal. Already we have done evaluation of the left side limit of x approaches 0 for the function f of x. It's over here. So its evaluation is just 1. And also we have done evaluation of the right side limit of x approaches 0 for the function f of x. We have done it over here. Its evaluation is just 1. So both of them are finite and also they are equal. So whatever value we are getting for the left side limit and the right side limit, the same value should be taken for the ordinary limit of x approaches 0 f of x. That is the ordinary limit of x approaches 0 f of x is equal to 1, but it's given 3 over here. So already we have done evaluation of the ordinary limit of x approaches 0 f of x, it's equal to 1. But the statement B says that the ordinary limit of x approaches 0 f of x equals to 3. So this is false. So statement B is false. Now we can check the statement given in part C is true or false. That is f of x is differentiable at x equals to 0. Since we have to check whether the function f of x is differentiable at x equals to 0, we have to find the derivative of the given function f of x. For that, let me write the given piecewise function f of x as it is. That is f of x equals to x square positive 2x positive 1 where x is less than or equal to 0. And we have another piece that is 2x positive 1 where x is greater than 0. Now let me find the derivative of this function f of x, that is f prime of x equals to, when I find derivative of this expression, particularly the first term over here, the derivative of this x square is 2x and the derivative of this 2x is just 2 and the derivative of this constant positive 1 will become 0 and we can write the stuff over here, that is x less than or equal to 0. Now let's get derivative of the second piece. When I get derivative of this 2x, I'm just getting 2. The derivative of the constant positive 1 is 0 and here we have x greater than 0. Now, f prime of x is a piecewise function where the first piece is 2x positive 2 when x is less than or equal to 0 and the second piece is just 2 when x is greater than 0. Now to check f of x is differentiable at x equals to 0, I have to evaluate the left side limit of x approaches 0 for f prime of x and the right side limit of x approaches 0 for f prime of x. Both of them must be finite and equal. Then we can say f of x is differentiable at x equals to 0. Okay, now let me evaluate the left side limit of x approaches 0 for f prime of x. So here I have taken negative sign. So it indicates x approaches 0 from its left side. So that is when x approaches 0 from its left side, all the values taken by x will be less than 0. When x is less than 0, the piece we have for f prime of x is 2x positive 2. So that is, I have to plug in this 2x positive 2 for f prime of x over here. Then I am getting limit x approaches 0, 2x positive 2. Okay, let me do it. Now what we have to do is we have to plug in this limit 0 for the x over here. This negative sign has nothing to do with the calculation part. It just indicates that x approaches 0 from its left side. Okay, now let me plug in this 0 for x over here. Then I'm getting 2 times 0 positive 2. 2 times 0 is 0. 0 positive 2 is just 2. Okay, now let me evaluate the right side limit of x approaches 0 f prime of x. Let me do it. So here I have taken positive sign. It indicates that x approaches 0 from its right side. When x approaches 0 from its right side, the values taken by x will be greater than 0. So now we have to consider the piece of f prime of x where x is greater than 0. When x is greater than 0, the piece we have for f prime of x is 2. So now we have to plug in this 2 for this f prime of x. Let me do it. Limit x approaches 0 positive. 2. So as I said, for this negative sign, this positive sign has nothing to do with the calculation part. It indicates x approaches 0 from its right side. Now to evaluate this limit, what I have to do is I have to plug in the limit of x, that is 0 for x in the function over here, but I don't find x over here. So the evaluation of this limit is the same constant 2 we have over here. Okay, now I got the left side limit of x approaches 0 for f prime of x, and the right side limit of x approaches 0 for f prime of x. Both of them are finite, that is 2, and also they are equal. Since both the left side limit and right side limit of x approaches 0 for f prime of x are finite and equal, we can say that the function f of x is differentiable at x equals to 0. So the statement we have in part C is true. So among the three statements, only the two statements are part A and part C are true. The second statement, part B, is false.